vectors have a size or magnitude and a direction. The common vectors you're going to come across in this unit are displacement, velocity, acceleration, and a whole range of forces such as weight, friction, tension, normal reaction, and thrust. Now, probably the first type of vector you came across was this column vector form, which you hopefully will have come across when you've done transformations at GCSE level. And of course, remember that this at the top here tells you how much to move in the x-axis direction. If it's positive, you move to the right. If it's negative, you move to the left. And this one down here tells you how far to move in the y-axis direction. If it's positive, you're moving up. If you're negative, you're moving down. So you will be introduced and find a new way to write vectors using what are called unit vectors. So as it sounds, it means that the size of each of the vectors is just one unit, whatever units the question is involving. And what you'll find is that I is used to indicate the x direction, J the y direction, and K the z direction should they put in any 3D. So the column vector that you can see above would be written as 5i plus 4j. Now there's another way in which they might describe a vector by giving its magnitude, which is r, which is represented by the length of the line, and its direction given by theta, the angle, which notice is the angle between the vector line and the x-axis, the positive x-axis. So looking at the diagram we've got here, you may be asked to write it in the unit vector form instead. So to do that, we need to know what it is in the x direction and the y direction. And to help us sort that out, we're going to use some SOHCAHTOA. Drop in a line here. What we can see is this is opposite that. So we've got the opposite and we've got the hypotenuse. And so this one would be r sine theta. Whereas this length along the bottom here is adjacent to the angle. So that would be r cos theta. And so to write this vector, r theta, in its unit vector form, it would be r cos theta I plus r sine theta j. Now you might be asked to go the other way round, so be given the unit vector form and being asked to turn it back into the other form. So what you can find, and you can do this by Pythagoras for the magnitude. So if you imagine you've got your triangle here, this is the x, this is the y, so we know by Pythagoras that this one here will be the same as x squared plus y squared all square rooted. So that's where that comes from. And then this is our angle theta here, and so we can see that the tan of theta would be y over x. And so theta is tan to the minus 1 of y over x. Going to look now at the common terms that you need to be aware of in connection with working with forces, diagrams and problems. So when it says that it's a particle, then it means that it has no dimensions, no width, height, length. So it's treated like a little dot. If it's light, then it means it has no mass. If it's static, that means it's not moving. Rough means that you will have friction involved in the situation, whereas smooth means that there's no friction. So a beam or a rod is just a long particle, and so effectively that makes it just a line. Uniform means that the mass is evenly distributed. Which means that the mass will act at the centre of the rod or beam or whatever it is that you're using. So obviously non-uniform means the opposite. It's not evenly distributed, and therefore it's a trickier situation in terms of working out where the mass is acting, but generally speaking you tend to get uniform objects. Rigid means that there's no bend in it. Thin, surprise surprise, means no thickness. Equilibrium means that there's no movement, which means that the forces are all balanced. Plane is a word for a flat surface, and inextensible means you can't stretch it.